So hi all of you. So we'll start the session. Right. So can you see my screen, all of you?
Yes, sir.
Yes,
Yeah. Okay. Thank you. Right. So thank you for joining all of you. So today's webinar on physical AI. So today the world is moving towards AI plus physical things. We know that, right? So AI plus physical things. So integrating artificial intelligence into everyday hardware like refrigerators, washing machines, watches. Okay, so I'll be talking about how you can add AI into the hardware. Okay, so through hands-on, how you can do that. So I'll be showing you everything with practical demonstration so that you can do this next time and you can build various projects also. I'll be showing you how you can do that, right? So most of you know what is AI, right? So AI, most of you know that AI can do almost every task because AI can think. So AI capabilities we know because most of you are using ChatGPT, Claude, other LLM tools, generative AI tools. So we know that AI can understand, AI can think, AI can think, AI can decide and then plan. So all these things can be done by the artificial intelligence, right, all of you? So the ability of machines or softwares to think, learn, and make decisions like humans, right? So today robots can walk, they can pick, they can be autonomous. Even cars, drones, everything is autonomous because of AI capability. They can think, right, all of you? So that is AI. So in AI, there are many things like ML. People talk about ML, machine learning, deep learning. So I'm not going to give more details about all these concepts, but I'll be focusing more on how you can combine AI with the hardware. Okay, so machine learning, deep learning, computer vision, and then Gen AI, AI agents, agentic AI, multi-AI agents. So all these things are generally AI capabilities. Most of you know that, right? So these are the different things you can do, right? So you can integrate ML with the hardware. You can integrate deep learnings, with the hardware. Computer vision capability you can provide to the hardware. Gen AI capabilities you can provide to the hardware. Okay, you can create agents. Okay, those agents can be deployed in the robots. You can do that. So what is Edge AI? So Edge AI is all about how you can run AI, understand. So you know what is AI. So AI can understand, think, it can make decisions for you, right? So all these things it can do. So if AI can do all these things, then if you combine this AI with devices, so if you deploy same AI in the device, suppose you have a device like smartwatch. Suppose you have smartwatch and just deploy this AI into the smartwatch, then smartwatch capabilities increases. Okay, it can think. Now smartwatch can think. Now smartwatch can decide, right? So those capabilities will come to the smartwatch when you deploy AI into the smartwatch. Okay, so you can deploy into any like hardware like microcontrollers, microprocessors, GPU based systems. You can deploy your AI. So it depends on the size of the AI model, artificial intelligence model. It varies, like hardware varies, because if the big size AI model cannot be deployed into a small, microcontroller, right? But small size AI can be deployed into a microcontroller. We will discuss what microcontrollers or what systems you need or what devices do you need to deploy AI. Okay, all of you. So hope all of you are able to follow, right? Right, following everyone?
Yes, sir.
Yeah, thank you. So when you see, almost everyone knows when you build AI system. Okay, suppose you are creating AI system. Suppose simple example, stock price predictions. Suppose you want to predict stock prices. If you build a stock price prediction, so initially we build everything in our computers, in our machine, right? After that, we have to deploy. There are two types of deployments. One is cloud deployment. This is the general use case. If you are working with web or applications, basically cloud is preferred. Okay, so your stock prices, it is actually web based, right? So you have to deploy on the cloud. Sometimes you need to deploy your AI into the local devices. For example, motor, you have to integrate with a motor. Suppose you want to understand what is happening to your motor, then you have to use AI on the motor. Suppose you want to do some analysis on bus engine. So bus engine, directly you can integrate AI with the bus engine, right? That is actually local integration, right, all of you. So there are two types of deployments in general, edge deployment and another one is cloud deployment. If you're deploying on edge, then it is edge AI. And if you're deploying on cloud, then it's cloud AI, right? So when you need cloud, when you need edge AI, understand if the security latency, latency means, you don't want any delay. You want everything done very fast. Okay, so then basically you have to go with the low latency things. Okay, low latency means it should not take more time to give the results. The action should be done immediately. Okay, in such case, generally edge AI is preferred. Okay, because it is very low. It is real time because we are not using any network. There is no internet. Directly you are doing on premise. Okay, the motor is present directly on site. You are predicting what is happening to the motor and you are taking the action. If you are doing that, that is actually important for robots, drones. Today, if you see defense drones, military grade drones, so they need everything done in the drone itself. They cannot send data to the cloud because in military, they don't use much internet, right? If you are deploying something in defense. Okay, so the first thing is they don't want to connect to the external public internet, right? So they want everything local. Okay, in such case, this is very preferred. Edge is preferred, right? And internet is not required. Privacy high because your data stays local. Always remember. So most of the defense company general they want data to be stayed local, not exposed, right? So AGI is preferred if you have these things and if you want to do on-device processing instead of cloud, right? The scalability, the problem is if you want to scale, you need more number of devices, right? So if you have 100 devices, you can scale to 100. But if you want to scale to the more devices, then you need to buy more. Okay. So the scalable, it depends on your requirement, right? All of you. So initially capital cost is high for AGI. But once you buy, there is no need of recurring cost. Okay, but for cloud, you have to pay for it. I know continuously, and you don't own it, right? But AGI, you own the hardware. Hardware is yours, right? All of you. So these are the some important differences between AGI and cloud AI. So most of the time, industries when you are working with IoT devices or industrial IoT, or maybe you are working with predictive maintenance or SCADA system, PLC SCADA systems. There today, companies are investing to use AGI. Okay, because instead of collecting data and sending cloud and apply AI and bring the data back, results back into the systems, instead of doing that, to and fro distance traveling of the data, you can actually do everything locally in the hardware itself. Okay. So there are many use cases where you can use AGI. I'll be talking about them as well. So advantage of AGI, remember this, low latency, offline capability, privacy as I discussed, and cost efficiency also there. So that is why companies are moving towards physical AI, that is Edge AI. Okay, and real world use cases, smart surveillance. Okay, so today each camera is integrated with face recognition, activity recognition, anomaly detection. So directly camera can detect. So there is no need to send that to the cloud and do all the processing and bring. In real time, a camera can see about some a situation, and it can analyze what is happening. Some fight is happening, some people are quarreling. Okay, somebody is bringing a knife. Okay, so all this information in real time you can see in a camera. Okay, without you to see, basically camera can see and analyze it. Okay, and it can send you a report. And if there is an anomaly, automatically it can send you a message notification, right? So because cameras are now integrated with AI enabled cameras are coming, right? So because you are adding camera, and then device plus AI, then it will become AI based, camera, which can do everything for you. And also industrial IoT. So industrial IoT today, there are many things to be done on premise instead of cloud. So this is another very good use case. If you're working in IoT or PLC and SCADA, so it is a must to learn Edge AI, because AI is not now, separate for IoT engineers or PLC, SCADA, or whoever you may be. Okay, you need to adopt AI with the existing infrastructure. Okay, all of you. So healthcare also today we see most of the healthcare devices, for example, ECG machines. Previously, ECG machines cannot do every diagnosis, but now these machines are coming with AI, so that GE Healthcare, Siemens, all these industries, what they are doing is they are medical, they are manufacturing medical devices from past, few years, but now they integrated AI capabilities with these devices, and now they are capable to analyze everything on premise. Autonomous systems like drones, robots, cars, everything. Like if you see drones, now drones can do all the analysis. Okay, on premise. No need to send data back to the server. Robots are learning cooking. They can cook everything for you, right? That is possible. And then robots learn from the environment and they can clean everything for you, right? These are all very useful examples, use cases where AI is deployed. Okay, all of you, right? So there are many companies. I'm just showing NVIDIA, Google, Tesla, but there are many companies today. Small companies are using Edge AI. Okay, small companies are building products using AI plus hardware. So you can also try. So industries are adopting Edge AI. So there are many use cases you can find in Edge Impulse and other places. So you can click on this link and you can follow. Okay. So then you can see what are the different use cases. Okay, these are some use cases you can find. Fall detection with Edge AI. This is a healthcare product. Consumer devices. HP bringing voice control to earbuds and headsets. HP is integrating that voice control. And you can see here automotives, global sense drives, new standards in automotive diagnostics. And you can see here NVIDIA, Omniverse. Actually, this is used for asset tracking and monitoring and translating costs to actionable insights. So you can just go through this and you can identify how industry is using Edge AI for different use cases, right? In the infrastructure, industry, AI automated hard hat detection, ML powered agriculture robotics. So these are the some use cases on Edge Impulse. You can see. So Edge Impulse is a platform for developing and deploying ML models into devices or hardware. So I'm going to explain how we can build products using this as well. I'm going to show you demonstration. Right. So you understood what is Edge AI, right? I think no need to tell again. So these boards comes with processing power, memory, connectivity to perform real-time data processing and AI inference at the edge. So these are the capabilities of AI hardware. So there are different AI hardware are existing. So I'll be showing only few. there are many, like, ESP32S3 is a small size, AI hardware. So we are going to show some experiments with this. So today may be possible one, gesture recognition and gesture. So I'll be showing you that how to build, and Raspberry Pi 5, and then NVIDIA Jetson Nano, and there are other like Google Coral, is it Qualcomm. So there are many boards are there. Okay, so I'll be showing you only few boards, and you can see the capabilities of them. They have the CPU and also GPU capabilities. ESP32S3 no GPU, but Raspberry Pi is coming with some GPU core but no NPU. But here you can see 128 core GPU is powerful. So NVIDIA Jetson is powerful. So the cost also very similar kind. When you see power consumption is low, but they consume more NVIDIA Jetson, but it is powerful to run DL, computer vision, generative AI applications. This is good for sensor data predictions. Okay, if you want to work with the sensor data and predict, so for example, gesture recognition or anomaly detection of a machine, so you can go with the low power things. Okay, like AES-led because it supports MLDL. So you need to understand one term like TOPS and GOPS. So TOPS is 10 operations per second, 10 to the power 12 operations per second, and GOPS is giga operation per second. So generally, when we talk about the performance of any hardware, we see them. Okay, for example, Jetson, if you see, they comes with 40 to 67 tops. So they can run YOLO for object detection, LLM for generating text and voice, and STM32 comes with the GOPS only. So you can run only small models. Okay, so when you choose this hardware, how to choose the hardware for running your AI basically depends on what you are going to run. If you're running LLMs or computer vision models, then you have to go for TOS. Okay, if you're running just small sensors, like temperature, anomaly detection, or you want to see what is happening to the machine using sensor data. If you want to use small machine learning models like KNN or maybe other model like regression model or classification model, simple models, then you can go with the STM32 or ESP32S3. Okay, all of you. Right. So here you can see some hardware mostly people are using. So NVIDIA Jetson or in Nano. Already I show other boards in the previous slide. Okay, and Google Coral, Android K210, STM32H7. You can see tops here. It is topping 40 to 60. Others are not having that much power, but they are capable, because if you want to use in a smartwatch, no need of Jetson or in Nano or Google Coral. Okay, you need some low power because smartwatches runs on a battery power, right? So they should not consume more. If they consume more power, then you cannot do that, right? So you have to use some millivolts, okay, milliwatts like this or microwatts. That is good, right? So the choice of the hardware for your project or for your product depends on depends on what exactly you want. Okay, what is the purpose of designing it? Okay, so based on that, you have to choose the best, and you have to see all these parameters to choose the best. Okay, of you. Right. So these are some boards. So we are going to work with hardware. So I'll be showing you what is the hardware we'll be using. We are going to use our own board. So we designed our own board for this. I'll show you what is a board and how you can use that board. Okay, of you. Right. So next all of you. So machine learning, most of you know machine learning. How many of you know machine learning here? Yes. How many of you know machine learning? Right. Nice. Excellent. Excellent. Right. Thank you. Thank you so much. So see all of you, machine learning is a subset of AI and data science. When you talk about ML, so ML is all about improving your machine performance, improving your machine performance by giving experience to the machine. So the experience generally, the experience, when you provide experience to your machine, machine performance improves. Why? Because its decision making, thinking capabilities increases. So experience always improves in a human also. If you give experience to a human also will make decisions properly, correctly, right? So there is a difference between a person without experience and with the experience, right? So what you can do is if you add experience to a machine, then machine can do very well, right? Or if you add experience to a app can do performance very well, right? So how you can add experience to a system or a machine? By using machine learning, right? So machine learning is all about how you can improve the process or the system performance or machine performance using experience, right? So it purely depends on algorithms, mathematical models instead of programs, right? Do you understand this? So machine learning is all about creating a model, okay, so that the model can predict, can classify, okay, right? So there are different types of machine learning like classification and clustering. So for example, you want to classify whether this is a cat or dog, then machine learning, you can use machine learning model to predict whether this is a cat or this is a dog. Okay, there is a classification problem, clustering problem also. You can cluster. This is used mostly in medical science images. So or SAR images you can use. So machine learning workflow, basically experience is required. So data collection, data is experience. You have to give that to the model. So algorithm. So that is training process. Then the model learns from the data. Once it learns from the data, then it can behave as per the experience, as per the data, right? And then you have to test it and then deploy it. This is how machine learning, you know, works, right? So once you get the model, so once you test it, if it is okay, this trained model will be deployed in the cloud or will be deployed in the, edge device, right? Either you can deploy in the cloud or you can deploy in the edge device, right? Hope everyone is following, right? So ML training and deployment. So once you train your machine learning model, then you can make live predictions by deploying either in edge device. Okay, so this is how you can do that. So you need something like, so you have to deploy somewhere, either in the cloud or a device. You have to do that. Okay, so up to training, that is actually one process, and deployment is another thing. So deployment, you need to know DevOps if you want to deploy on cloud. Okay, so we call it as MLOps, MLOps, ML operations, right? And basically you will be getting predictions either you can deploy on cloud or in the edge device. So challenges in model deployment, basically if you want to do deploy in the edge device, one thing is you need to check about the model size, how much time it is taking to predict, because basically computer predicting in the computer is different than predicting in a small microcontroller, right? And also how well it is optimized, the code size is reduced or not. So these are the some challenges generally people face. Okay, and because there are some trade-offs you have to do. Trade-offs means what microcontroller I have to use, what is size of it, what is the cost of it, right? If I'm deploying a model, okay, what happens? Because when you are adding AI capabilities, the cost of the product might increase, right? So it is very important as a business people, right? We need to understand, whether I can build in the same price without AI and AI, if approximately similar kind, then that is better. Okay, so the price should not be more, right? So you need to take care of that. So Edge Impulse, we are going to use Edge Impulse. So Edge Impulse is a platform. So I'm going to teach you Edge Impulse because Edge Impulse will help you to build everything. It's like a low code platform. So everything it can do for you. right? So starting from sensors, devices, here you can add devices, collect data, process it, pre-processing, training, deployment, everything will happen in the platform. So there are many companies who are using this, even Sony, Qualcomm. So actually, this was actually Qualcomm company. Edge Gimbals is a Qualcomm company. You can go through that and you can see this actually Edge Gimbals is Qualcomm company. Okay, you can see here Edge Gimbals in care of Qualcomm Incorporated. So previously Edge Gimbals, is a company, but now it was, uh, you know, acquired by Qualcomm. So the advantages, as I told you, like it's a low code platform or no code, data collection, model training, deployment to the edge, everything happens within the platform, right? All of you. So TinyML, there is another term TinyML. So TinyML is basically very similar as AGI. Okay, these are interchangeably people use. So incorporating machine learning into your tiny hardware components is called as TinyML. TinyML. So TinyML, where if you want to integrate, for example, you have embedded systems. Embedded system means how to write programs in the hardware, how to build doorbell, how to build home automation product, how to build smartwatch, how to build a embedded system product. But now you want to add embedded into that. That's actually concept of TinyML. Okay, so like embedded systems and IoT concepts are very important. You need to know basics or at least how to write programs into the embedded, microcontrollers. If you don't know, you cannot design AGI boards because AGI requires coding of hardware, right? It's not just a Python code that you write in a notebook or a Python code that you write in Python, editor, okay, or Visual Studio. You have to write the programs into the controllers. Okay, that's an essential skill you need to know, right? And there are different embedded systems devices you can find in the market. So TinyML has the potential to transform the world of you because Alexa, Google Mini, all are using TinyML Edge AI. Okay, so all these products you might be, using some of them, or you have seen some of them, right? So almost all these are powered with TinyML or Edge AI. Okay, so there are different sensors comes with embedded systems like ultrasonic, microphone, camera, gyroscope, accelerometer. Today, I'm going to show you a demo with this sensor, accelerometer sensor. I'm going to show a demo how we collect data and how we can sense and then predict. So prediction is key, right? So ML means prediction, right? So we have to predict something, right? So we are going to do that now. So tiny applications, you can use different use cases. So this is the first generally tested very many people collaborated like Microsoft, Nordic Semiconductor, uBlocks, all are actually collaborated and tried to build a first AGI application. There are many other applications are there. This is openly done with the collaboration. This is actually Elephant Edge. So actually, this was Elephant AI is a set of the Elephant AI they created. This is a set of machine learning algorithms to help in elephant conservation and protect them from poaching. So poaching, what is the poaching? Illegal trafficking and killing of elephants. So to stop it and to preserve the elephants, they designed this Edge product, Edge AI product. So what it can do is it can actually help to monitor. So basically why people hunt, there are hunters who hunt for ivory tusk and also for fun. So to stop this, so solution, they are using sensors, human presence detection. Is there any human near to the elephants? Or if there is any elephant movement, what is happening? So they can monitor sound, movement, all these things they are monitoring and they are understanding by using AI. So this how you can develop applications. So we are going to develop a similar kind of application now. So this is our AJ board we develop with the Edge. These are the specifications of our board. So this is actually ES30, S3 CPU. This one is a CPU, flash memory 16 MB. AI acceleration vector instructions optimized for ML. So we can run ML into this board. And also it comes with Wi-Fi, Bluetooth, other capabilities as well. So this is our board that is we designed, and it has a different sensors like microphone, amplifier, temperature and humidity sensor, ambient light sensor, motion sensor like accelerometer, gyroscope, and we have RGB LED, buzzer, camera, micro SD card. So all these sensors are present in our hardware. We designed this hardware mainly for Edge AI research and learning. Like you can do different use cases like smart surveillance, voice control, gesture recognition, industrial IoT, smart home automation, wearable devices. So all these things you can build and you can try with our hardware. Okay, Lafi. So I'll be showing you how you can do that. Okay. So how it supports AGI, our hardware. So it is that to do S3 supports AGI through built-in AI separation. And also it has a memory of 16 MB that is added advantage. Okay. Right. So we'll start deploying ML models on Edge device. So I request everyone, please log into Edge Impulse if you are doing the experimentation. If you want to see, just see the procedure, and later you can try doing this. Okay. So I'm going to do that now. So for any questions or anything, right? Any questions? Anything you want to ask? Yes. Any questions? Right. So I'll be showing you how you can actually use AGI for building, products. Okay, so first we'll start with this Edge Impulse, which is low code or no code platform for doing that. So you have to start with the login. So get started. Right. So this actually already I have account. So I'll log out. Now basically you will see this page when you click on start. Basically you will see this. So you have to click on sign up to do this. Right. So these are Edge Impulse, all of you. So you need to sign up and you have to create an account in Edge Impulse. And all of you, we are going to build a simple project, a hand gesture recognition project using Edge Impulse. I'll be showing you how you can do that. I'm not going to show big thing here. So just I'll be demonstrating because data collection is a tedious process, For most of the ML AI applications, data collection is key. So you need to spend time to teach the algorithm to learn, right? So it requires more time, but I'll be showing a simple project so that you can see the entire process. Okay, right. So see, this is the process how we are going to do now. So this is a block diagram. So overall architecture, simple, right? You can see here, first one is actually the flow, understand the flow. So these actually gimbals, okay? And this is our hardware. So in the computer and hardware together, this is actually computer and hardware together, what we are going to do. So we are using our hardware, ESP32 S3 hardware. So first we have to collect data. So for collecting data, we are combining ESP32 S3 with MPU 6050 sensor. So this MPU 6050 sensor is accelerometer plus gyroscope. So means it can help you to find movement. Accelerometer is generally for finding what is movement, mainly for distance, movement. Okay, whereas gyroscope is for angular velocity. So those things you can compute. Okay, so acceleration we can find here. So acceleration AX, AY, AZ, acceleration along x-axis, y-axis, z-axis. So using our hardware plus this sensor, we are going to collect. So when we move, automatically this AX, AY, AZ changes. So we want to collect that particular changes. So for example, movement like up and down movement, up down movement, left right movement. So suppose there are two movements. One is up down movement. So you are moving up and down. That is up down movement. And then you are moving left and right, left right movement. So when you do up down movement, So X, Y, Z values will be different. When you're doing this left and right movement, X, Y, Z values will be different. And when you keep the sensor idle, basically there is no movement. And then X, Y, Z values are different in that case. So I'll be considering three cases: left, right, up, down, idle cases, and we try to collect data. Okay, this is a simple case because it doesn't require more time to do that. Okay, so that I can easily show how we can do that, right? And then once you collect, how to collect? Basically, you need some interface, that is data forwarder. So data forwarder should be available in your computer. Then you can send the data to the uh, edge impulse, that is actually data ingestion. Once you get the data, so data labeling should happen here. Labeling means in machine learning, labeling is important. After that, we have to pre-process the data. These are digital signal processing block. You can apply different types of processing techniques. And then model training. Once you train the model, then you can test the model. After testing, you can quantize. Quantization means converting large size a model into the small size model so that you can deploy that into the edge device, that is ESP32, right? So once you quantize it, then you can download, that is export. So we are going to do that in Arduino so that you can easily do experimentation, right? All of you. Once you export, then it will go to the hardware. So you have to download this and you have to upload into the hardware. Then your hardware will behave like a AGI device. Then automatically it can detect whenever you move up and down, it will say up and down. Whenever you say move left and right, then automatically it will say left and right. If you keep that in idle, then it says idle. So automatically it can detect things, right? So we are integrating this with one of our customer project, smart city project, where government wants to keep devices secure. To make them secure, we are using this accelerometer to detect the theft and other things. Okay, theft detection, if there is any movement detection, if somebody is tampering the hardware, because government devices, many people try to dismantle or they want to take away. So these things we can overcome by using this particular one. This is a simple example use case, right? So for doing this, first step is creating an account. So you need an account in Edge Impulse. Okay, so please do create an account. So I'll be giving my account. And then username. So I'll be giving some username here. And then password. So I'll be showing the entire process so that you can later do it. So you can give any role here. Okay, so just provide your email and then username, password, then sign up. So done, right? So you can see here sign up successful. You can click here to build your first model, right? So I don't want to read all these things. Just I'll click on here. Yes, start manual. Yes, quit this tutorial, right? So now everyone can see here Hubits 1, project 1, right? All of you. So now we are ready. Okay, now there are different ways to get the data. You can add existing data. Suppose you have some Excel file created, then you can upload it. Or if you want to collect a new data, you have to click on this. So here you can see you can collect data from the phone, or you can connect to your computer, or you can connect your device or a development board, right? That you can do, right? So I'll be connecting my hardware. I'll be showing you how I'll connect hardware. So when you click on this, connect your device or hardware, then you will see here Edge Impulse Data Forwarder. So in your computer, see, data is, for example, I'll be showing you just, so this is the hardware. So can you see the hardware, all of you? So yeah, can you see this hardware? How many are able to see this?
Yes, yes.
So this is the hardware. Okay, this hardware is actually a J. So we are going to connect this hardware. So this is a wire. Okay, so you can see this wire. So this is a USB connector. So I'll be connecting this USB connector to my computer. Okay, so you can connect, right, all of you. So this is how we connected, right? Once we connect, so this to the hardware, right, computer. So this is connected to the computer now, right? So now from this device, so this device contains accelerometer. Okay, on this device we have MPU 6050 sensor and other sensors also there. There are different other sensors also existing, right? So, but we are going to collect data from MPU 6050 sensor into this microcontroller. From the microcontroller, data flows through the wire. So it will come to the computer, and we want to read it. So for this, you need Arduino. I'll be opening how to read MPU 6050 data. You need actually Arduino installed. If you don't have Arduino, basically you have to go to Arduino and you have to download. So for Arduino, downloading Arduino, you have to go to here. So this is Arduino Home because it is easy way to start learning. Okay. So because no need to use Arduino, there are many other things also there. For learners, it is always good. So my suggestion is, if you are a learner, it is better to start with the Arduino and then you can move with the other things. Okay. So this is my Arduino. Yeah, 1 second. I'll be sharing my screen. Just give me 1 second. Right. So I opened my program. So this is Arduino. So basically, if you see here, this is Arduino .cc, right? All of you can see here Arduino.cc. So this is Arduino, right? When you click on this Arduino home, you can see Arduino. You can download Arduino IDE. So in the products, you can see, so there are different products, Arduino IDE. This is the software to write and upload the programs into the microcontroller that I have shown to you. Right, you can upload to different microcontrollers from here. So you can download and you can install in your free time, because download and install will take away our half an hour. So I'm not going to show how to download and install. Okay, later you can contact us and you can learn how to download and install the hardware, right, all of you. So is that fine? I'm not going to show this because it will take more time to download and install. Okay, right? Right, all of you. Say yes or no, then based on that I can move forward. Yes, following everyone. Yeah, thank you. Thank you so much. So we'll move forward. Right. So once you install, and this is the simple program. So this is a program written to read accelerometer values, AX, AY, AZ. So acceleration along X, Y, Z. Okay, this MPU 6050 is a I2C sensor, I2C. So we have to, use that I2C address, 69. This is a register address. So from there, you'll be getting data from the sensor into the our hardware, that is ESP32, right? So once you get the data, we are printing the data on this, and why dot begin, MPU.initialize. This is the code to read and start initializing the reading of the data. Once you start, and then MPU.get acceleration, it will give you the acceleration values AX, AY, AZ, and you can print those values. This is a simple program to read and print acceleration values from uh, you know MPU 6050. So you need some things. So like, I'll be showing you after signing successful, you got the project, right? So we are going to connect and use this Edge Impulse data forwarder, right? So how to download Edge Impulse, data forwarder. So you have to install this Edge Impulse data forwarder. That is important, right? So to install Edge Impulse data forwarder, so I'll be showing you why it is required, because once you read the data, so see, when you upload this, you'll be getting the data, but this data should go to this platform, that is our Edge Impulse platform. So we have to get the data into the this platform. So there must be, see, Arduino only can read and display the data, but it cannot forward to the Edge Impulse. So there must be a connector between this and then to the edge impulse. Okay, so data will be fetched and then will be sent to the edge impulse. So we need to install a software which can actually connect both. Okay, that is a forwarder, right, all of you. So we need to install this. So I'll be showing you. So these are data forwarder. So edge hyphen impulse hyphen data hyphen forwarder. So when you start, actually, you will see all these details, but it should be installed, right? You can go to the installation. You can see how to install. So there are some prerequisites you have to do. First, you have to create Edge Impulse account. Simply, it is better if you can bookmark this. Then you can use this later, right? You go to Windows. So I'm using Windows machine. If you're using other machine, you can choose based on that. And you can see the instructions to install the data forwarder, right? So you need Edge Impulse CLI. That is important. So Edge Impulse CLI is important. So we are installing. So for that, you need to create an account in Edge Impulse, and then you have to install Python 3. Any doubts so far? No doubts, right? So I can go forward. If you have any doubt, you can just ask. I can give you. Okay, you can type also in the chat. I can check in the chat and I can give you a reply as well. Okay, right. So you need Python 3 and Node.js. These two you need to check as a prerequisites. Okay, and also you need additional Node.js tools. That is also very important. When you install npm, that is Node Package Manager. Okay, that would be funny. So that is actually npm. npm also required along with Node.js. This npm. So npm is actually useful for installing various Node.js libraries. Okay, most of you know. Okay, you need this as well. So once you have, so these are the instructions, right? Once you have all these, then you can use this command to install Impulse CLI. Okay, all of you. So if you have any issues, you install Visual Studio Installer, which will enable other tools required if anything goes wrong. But generally with these tools, it will work. Okay, right. So you have to just type npm space install -g space, because already I have installed, so I don't want to show this again. But you can see here what you have to do is open the terminal, and then so terminal you have to just open your command prompt here, and then you can type the command and you can install. You can install automatically, it will be installed all of you. So you have to use this command npm space install space -g edge impulse CLI force. So this will automatically install edge impulse CLI, right, all of you? Hope this is clear, right? And for more details, you can just come and see this documentation, which will help you. Once installed, okay, so you have to connect your hardware to the PC. Already we connected our hardware to the PC. We have done it, right, all of you? So, and then, basically once you do this, then we can move to the next important thing. So that is working with the Edge Impulse data forwarder. So there is a data forwarder, which is very important for us. So I'll be showing you how you can use the data forwarder. Carefully listen to the steps. So these are data forwarder, all of you. So you have to use the command like the Edge Impulse data forwarder, or already if you are using from past, and if you want to refresh the or configuration or clear the configuration, then you can use this. Okay, edge hyphen impulse hyphen data hyphen forwarder space hyphen hyphen clean. When you do this, then it will ask you your username. What is your username? Email ID. What is your password? Okay, you have to provide your password. Then it will start connecting to the, because it has to connect your computer from your computer. It should connect to the edge impulse, right? So that is important. So it should be connected to here. So because already I have account here, right? So our account is this. You can say this is the account, my account. right? All of you. So when you have this account, if you want to connect to this, then what you need to do is you have to provide you this particular email ID and password. So you have this is the email ID. Okay, I have to provide this email ID, and I have the password. So already I have set up the password. So I have to use the password. If you want to create a new password, you can create new password. So I have to activate this. So this is very important. If you don't activate, you'll get a problem. So just activate this. The account is activated now, right? And just refresh this. Right, done. So there is no issue now. You are ready, right? All of you. Okay. So these are the things you need to connect. That is important. Now, before connecting, so hope all the steps are clear, right? So we
Uh,
installed
I
Edge
have a doubt.
Impulse. Yes.
Yes, suppose I have my server in cloud, okay, and the data is stored at the cloud. How to connect this Edge Impulse with the cloud data through Web API? Whether the same
Get,
procedure or
yeah, your
this?
your question is not clear. Can you please repeat? I'm sorry for that.
Yes. Suppose I have my data archive in cloud, data archive of my industry in the cloud. Okay. To
Okay.
connect this to the Edge Impulse, I need to use web URL. Web API I have to use to send the data to Edge Impulse. So the
Yes.
same steps will be followed, or since it's an hardware which you are showing, so
Yeah,
the
see,
same
there
steps are
actually you
carried.
don't need of hardware, right? Because already you have the data, right? So
Yes,
it's
I
all
have.
about just, yeah, you have to add the data. So upload data or import from your project, you can do that, okay? Or you can add storage bucket where you can bring the data. There are different sources like Imagine S3, Microsoft, other, storages, organizational data set, or, upload from portal. All these are available for the enterprise. Okay, not
Oh,
for the developers. Okay.
oh, right, right.
Yeah,
Thank you.
yeah, thank you. So now we are going to upload the data, right? So I'll be showing you. So we installed, Edge Impulse CLI, and also we are ready. So once you are ready, what you need to do is you need to upload the program. So this is a program we have. So this program is only to read MPU 6050 isolation values. So we have to select the board and port for doing that. ESP32S3 dev module. So this is the module we are using because I'm using this ESP32S3, and we have to select the COM port as well and click OK. So now I'll be uploading this program into the hardware so that we will get the data, acceleration data, and that particular data we want to send to Edge Impulse. Yeah, it will take several seconds, just 1 or 2 minutes. Okay. So this is a program we are uploading all of you. So once you select the board and port and upload, okay, so there is a library. If you are, using MBU 6050 uh, sensor, basically you need to install a library. So you can find where here you can see. Here, 1 second. I got some compilation error. 1 second, all of you. Just 1 second. So now it is uploading. Now the code is uploaded and you can see here serial monitor. Now you are getting the acceleration values along X, Y, Z axis, right? So all of you can see the data coming along X axis, Y axis, and Z axis, right? So these are the acceleration values, right? So close the serial monitor because Edge, impulse data forwarder also uses the serial port. So if there are two softwares using the same port, then because of that there will be a conflict and you will get error. Okay, so you have to close this serial monitor, right? Now we will move to the next step of here. So once you get, so this is a library. If you want to install the library, so basically if you don't have the library, you have to install this. So you can find in Arduino libraries manager, and then you can see MPU 6050. So they are actually MPU 60 by Electronic Cats. So this is a library. So these are all free libraries you can install and you can get the data. It is easy. Okay, right. So once done uploading, now the next step all of you. So now data forwarding to Edge Impulse should happen. Okay, for this you need to run this Edge Impulse data forward. So this is essential to get the data into the our studio. Okay, so I'll be showing you that now how to do that. So we can do this practically here. So you can see the commands in this page, Edge Impulse data forwarder. So suppose I want to start with a new account. So configuration, everything I want to do new and then press enter. Sorry, just 1 second. So now it will ask what is your name or email. Okay, so I'll be providing my email, that is hubertsdigital@gmail.com. And then we have to provide the password. So you can see it is connecting now. So connecting to remote Edge Impulse, connected. So it detected, already data is detected. With the serial monitor, it got example values 1456, comma, -300, comma, 15508. So it detected the values and it is saying 3 sensor axes detected. What do you want to call them? Separate the names with comma. So I'll be giving AX, comma, AY, 3 axis values, comma agent, and press enter. So we are giving AX, AY agent for these three. What name do you want to give this device? ESP32 AI. So this is a device name and enter. So device ESP32 is now connected to project Qubits project 1. To connect to another project, you have to run this again. Then it will be clean and you can connect to that. Okay. So currently our device is connected. Now go to here, your project. This is your project. Now you can see one thing happened. So devices, a new device is connected. So type data forwarder. From the data forwarder, it is connected. So connected to data acquisition. So sensor with 3 axis, AX, AY, AZ, right, all of you. So this is how you can connect your device. Hope all of you are now familiar how to connect device. So once device is connected, now you can start with the data acquisition, right, all of you. So that is the next step. So we have done up to this, right? So once you do, if you log in with the Gmail, problem is the password will not be available. Remember this point. When you are logging with the social media or the Gmail into the Gimbals, there is a problem. You don't set password. But if you don't set password, you cannot connect with the Gimbals. Remember that point. Okay. Sometimes you might get problem with that. Okay, right. So device connected, now we'll start with the data collection, all of you. Okay, so you have everything here in this how I'll show you practically. So go to data acquisition now. Now you have to add data, right? So see, all of you already we are getting the data, right? So once you're getting the data, no need to add here because already you have this collected data. So there is a already live device is existing. So when the live device is existing, no need to use this here. Okay, so what you can do is here, you can use this device. So we are getting data from ESP to AI. Now labels, we start with a label up, down, up and down. And sample length, we are collecting a sample for 10,000 milliseconds. Okay, so that is 10 seconds wait. And the sensor, this is sensor data. And frequency at 48 Hz frequency, we are collecting data, right? So these samples will be collected with this. So we'll start sampling, right? So see, actually we are trying to show you everything in few seconds. Okay, so you can see how we are doing that. So we have to move up and down the. So all of you can see that, right? Can you see the camera? Yes, can you see the camera, all of you, along with the screen? Say yes. Anyone?
Yes, sir.
Yeah, thank you. So we can start sampling. So waiting to start. When it says sampling, you have to move up and down. So you can see like this, you have to move up and down because already accelerometer is present. So it is actually collecting the first sample. So done, first sample is collected. So this is a first sample. 10 seconds data collected. So there is no training and testing data split. So basically for machine learning, data should be split into training data and testing data. So again, we'll take another sample, start sampling. Right, again, we are moving up and down. So next sample is collected. And again, we'll do third sampling. Right, so this is third sample. Oh yeah, that is correct, Joseph. Okay, so three samples. So we'll connect another sample, right? Okay, so I'll be taking another sample as well. Yeah.
Excuse me, sir.
So are you, yeah, yes, yes.
Actually, every time we are collecting the data, you are clicking on that button, like on the site, right? So can't we make it automatically to collect data? Like
Yes,
your
AI
thought
labeling also there.
sampling, like
Yeah, so you can try with the AI labeling. So continuously you can increase the sample size and you can collect and then you can try with the AI labeling as well. This is a new feature, but you can try with this new feature. Okay.
yeah, okay, sir.
Yeah. So we collected up and down, but actually data collection is always, the process is, very tedious generally. And it depends, like, you can actually try auto labeling as well, like AI labeling features are there. So now once up and down is done, then you can try left, right, left, right. The labeling should be very clear. One name, if you are giving the same name, you have to use again, left, right. And now you have to change the movement, right? So camera is visible to everyone, right? Right. Thank you.
Yes, sir.
Yes.
Thank you. So likewise here also we will collect, four samples. Right. So we collected four samples and ideal condition also we collected four. So here we don't move. Right. So once done, now we have to separate training data and testing data. So I have taken small sample set for time being. So now what we need to do is we need to choose some samples for testing. So I'll be choosing one sample from idle because we have to choose in uniform. So like all the labels should be present, left, right, up, down. So there are three samples, one from idle, one from left, right, one from up, down. So these samples I have taken and I'm moving to the test because training phase we train the model and then after that we have to test. So for testing we need testing data, but actually I'm taking only few samples, right? But you need to collect large amount of data for making your model work with more accuracy and also for your device to predict accurately. Okay, right, move to test. Yes, move. So now testing data, you can see here 75% and 25%. Okay, 70% training data and 25% testing data. It depends on your data set. You have to choose, like generally 75-25% is okay. Some people choose 80-20 ratio as well. Right. So we have the data now. So we are getting the data, right, all of you. So once you have the data, now we have to move to the next one, right? Even you can see here data explorers, you can try exploring. Okay, but what we want to do is, so we want to move to the next one. Okay, so that is actually creating impulse, right? So we are going to create impulse. So go to the impulse, right? So now here, what is impulse? Impulse is the place where you train. Okay, so first thing is training. Before that, you have to process the data. After processing data, training, and then model, testing. So this is mainly for pre-processing and training, learning. Okay. So target device. So I am building it for ESP32 family, but ESP32 family only one device is available. ESP5, ESP32. So I'll be choosing this. Okay. You can see what are the hardware available. There are many other hardwares are available like ST, Silicon Labs, Texas Instruments, Renesas, Raspberry Pi, Qualcomm, NVIDIA. Okay. So I'll be choosing this ESP240 and then custom device name, ESP32 AI device. So you can save this. So once done, now we have to start with the processing. So this is actually processing block and is a learning block. So these are very essential. So add processing, right? All of you can see here, you can flatten the data, you can do spectral analysis, you can go for extract a spectrogram, so on. So what I want to do is I'll be choosing here spectral analysis, right? All of you. So click on this spectral analysis for FFT, right? You can see here spectral analysis. It depends on your requirement. Okay. So the AX, AY, AZ, these are the features we have, right? We understand this, all of you. So after that, we have to go to the learning block. Click on the learning block, all of you. And then we are going to use the classification. So because this is a classification project, so you can see here great for categorizing movement or recognizing audio because we are, using here the movement recognition. So you have to add this classification, right? All of you. So once you have done this, like spectral analysis, classification, then output features for three labels, either it has to tell based on the sensor data, it has to predict whether it is idle, left, right, or up, down. So now you can save the impulse. Right, all of this. So saving impulse is done. Right now you can move to the next one. That is spectral features. So these are the spectral features, right? All of you. All of you can see the data here. Right. So you can here you can select the filtering. So it's the low pass filter. So I'm choosing so that it can, so if any noise is present, it automatically removes that. Okay, so that is actually low pass filter. So you can see different things like scale. If you want to use a low pass filter, a high pass filter, you can check the order. So we are actually using FFT. So, and then we can save the parameters right above you. Once you save the parameters, done, right? So once done, so we can move to the next all of you, right? How many of you are able to do this? So you click on generate features. So it will take some time. So you can see here feature generation output. So like creating job and then job schedule, preparing for the environment. So it will be generating the features for your next stage. So this is actually doing pre-processing. Generally in machine learning, we do this in Python, right? So we use NumPy, pandas, and then we do this entire process. But here, you can directly do everything within the platform itself. So all of you can see here. So it is actually takes some time calculating. This could take a few minutes, all of you. So if you have a ESP to S3, you can also try working with this. So now, so you can see the data. So these two are actually this one is up down. This is okay, and then left right is also okay. So and then you can see here in the ideal case there are one or two cases where you see these features are mixed. So there might be some issue when you're predicting idle case or when you're predicting up and down or left right, because your data you have to try these things should be separated. That would be very nice if you get all these are separated like blocks. Suppose if you can make it as a group, if you can separate them clearly, then it is easy. But here we cannot separate all, right? Actually these here blue dots you have to see, but you are seeing green and orange as well, right? So if you can remove these, then it will be more better and you will get more better accuracy, but we will go ahead with the same for now, right? All of you. Now see, once we are ready with the features, now classification. So go to the classifier. So this is actually based on the neural networks, all of you. Okay, so neural networks, this is neural networks based classification. It uses by default neural networks, but if you have your own model, suppose if you have your own model, you can, for example, LGBM random forest classifier, or XGBoost random forest classifier, or support vector machine classifier, or maybe random forest classifier, logic regression, or ridge classifier, or ridge CV, or you want to build your own, right? Sometimes people want to bring their own models as well. You can do that, but it is supported in enterprise, not in the developer mode. Okay. So it is not actually available for the developers. It is available for the enterprises, those who pay, because developers it is giving free, right? And then here you can see number of training cycles means it is epochs, all of you. So how many times it should learn from your data, and is a learning rate, how quick it has to modify all the weights and parameters. So if the learning rate is less, basically it takes more time, but it would be a stable one. Okay, that would be better. And here you can see the training processor where you want to train. So these are the settings, right, all of you, and you can see the here input layer, reading features, dense layer. So this is the architecture. So I'll show you. This is actually neural network, all of you. If you are new to the neural network, just go through simple ANN, artificial neural network. So this is what exactly we are doing here. So number of training cycle 30. So this is actually related to how many times the model reads through your data. Okay, so that is a good starting point. You can change and you can try. So if you use too few, it is underfitting. If you are using many, then it is overfitting. So you'll get these problems when you increase or decrease. So you have to check how optimal you can do that. Learning rate is actually we are taking less value, but okay, this is small actually. It takes time, but it would be stable learning. Okay, love you. And learn optimizer we are not using. Training browser you can choose based on your requirement. Okay, right. So this is how actually neural network works. Basically input layer. So we are having 18 features from the DSP block. These features will go into this, and then dense layer where it learns. You have another dense layer. Finally, output layer. It is actually giving a softmax. It is using. It is giving 3 outputs. So basically for if you are using softmax is useful if you have more classes, more than 2 classes. Okay, right, right. So you can save and run. If you want to change, you can change all of it. You can save and train the model. Then the model training starts. You can see here trading job. Okay. You can see all the steps. View live view, tensor board, copying features from processing blocks, DSP block. Okay, pre-processing blocks, train the model. So epochs, it is running all the epochs. So it will be running 30 epochs total. After that, it will be, converting TensorFlow light float 32 model because we are using quantized one. 32 will be converted into int 8 all of you. That is actually 32 size will be reduced to int 8, which is very less. Okay, that would be very nice. So got it. Okay, you can see even training graphs and all here. Okay, so you can see here all the information, training model, epoch 1 to 30. So total 30 epochs it trained, and you can see what is the output here. Okay, after that converting TensorFlow light float 32 model into int 8 quantities because it reduces the size drastically. That is important. Model size. If you use directly float 32 model, then actually what happens? Most of the almost deep learnings when you train models will be in float 32. But you have to quantize it, reduce the size. So you have to use quantizer. Already we used. So after that, it will be checking the performance. You can see the performance. So our accuracy is not good, very less, 70%, because we have taken less amount of data. Okay, so we are getting this, right, all of you. So there are 2 models here, unoptimized 72.2, and then quantized you are 72.2. So the loss is 9.59. You can see here. So these actually confusion matrix. So confusion matrix, ideal, left, right, you can see 100%, but up, down, there is a problem here. So there's a misclassification, actual label up, down, but it is actually predicting as a ideal. So there is an error, 12.5%, right? So because we already saw in the images, there is a possibility that there might misclassification happens, right? So we have taken very less samples, 12 samples only. So we are seeing this. If you increase samples, actually accuracy will be 90. And if you increase furthermore, the accuracy increases to 95. Okay. So this is a
That's
matrix.
clearly sir.
Yes, yeah.
So yeah, how much of accuracy means that model is well and good?
Yeah, so you need to see different things. So accuracy is calculated like this. So for example, I have 100 labels. In 100 labels, 72% I am getting predicted actual labels as actual labels, but 30% actual labels are predicted as different labels. Actually, up down should come, but it is giving left right. Okay, so that is actually indication of this accuracy. So if the accuracy is more,
Depend upon
yes,
the data, input data.
yes, actually, if the accuracy is more, that is well. Okay, that is very good. Okay, so this is actually training accuracy. Understand? But real world training accuracy is different than testing accuracy. You have to check both training and testing. Okay, so and also you have to check where you are failing. So you are failing in one case here, right? So up down is actually shown as idle. So your actually a model is failing. So how to improve this? You have to check how to improve this. So you have to overcome that particular why we are failing in that. So individual also error rate you have to check. So here 12.5%, right? So and also you have to check ROC curve. It should be actually one, close to one. Okay. So ROC curve should be good. And these also should be performed well. Okay. Precision should be 90, approximately 90. For medical, you don't get more accuracies. Medical. Okay. It is very difficult if you are working for healthcare or medical. Okay. And F1 score also should be more. Okay. And ROC curve should be close to one. Okay, then it would be better. So you have to check along with the accuracy, these area under ROC curve as well. Okay. And also you can see here how you are getting, right? So there is a problem here. You can see what are the problems and why you are getting like this. So from this, you can decide whether to retrain or what to change. Okay. And next step is actually testing data. You have to try with the testing data also, right? So if you go to the model testing, all of you can see the model testing. So model training is done, right? Okay, these are model training. Once the model training is done, then go to the model testing. So now we have three samples, one from idle case, left, right, up, down. Now, how if you give them as input, what would be the response? Okay, so if you try classify all, so now we are testing them with the trained model with 72% accuracy. Right, so you can see here, but here you see test accuracy is good. Test samples are good. So you can see 86.67. So test accuracy is giving very good. And also area under curve 0.93, close to 90. So yes, you can use it for live classification. So if you see, yeah, this is not given for quantized. You can see this, right, all of you. Right, okay, so I'm trying for that as well. Yeah, still it is showing this. One second, I'll be doing it for this one also. Quantized means model with less size, that is optimized. Right, so now you can see for that as well, quantized. So we are getting better accuracy for both. Okay, both are same, right? We have very less misclassifications. One is left right misclassification 1%. Up down also there is one misclassification. Apart from that, most of them are classifying correctly, right? So this is how actually you can train the model and you can test it. After that, you can do the live classification also. If you want to do, you can go to the live classification. Okay, so for example, so you can see now in the video, Suppose if we move up and down, because see, we cannot say this is 100% it will be giving 100% correct, because we have just taken 10 samples. Okay, you need more, but we'll try. Okay, so this is actually ideal case. So we are just keeping that. It is collecting the sample and it will show the result. Okay, we are not moving it. Right. So now you can see here. So when you see this, actually the case result here, most of the cases there are 10 cases here. Timestamps, idle case, idle case, idle case. Most of them are mostly they are giving idle case, but not 100%. Okay, so there is an issue with up and down because there is an uncertainty here. Okay, so because we are using testing, you can see here. We can try again. So can you please use up and down? So now it is classifying. So now you can see it's showing up and down only. So there is no issue with the up and down. So up and down live classification is correct. So we moved up and down and is giving up and down only, right? So you're getting the result, right? So, but not, for idle case, it is saying uncertain because, the position moved. So because we kept just idly here, because it will be changing different positions, right? So the system should learn everything. Otherwise, it cannot clearly say. It depends on the probability, right? Predictions are probability of getting idle or getting up and down or getting left right, all of you. So if you try left right, we'll see how left right also works. Just move left right, just right. Now you can see the result. You can see here left right only, right? So it is clear, correctly classifying left right also, but it is actually not classifying idle case. We'll try again idle case once. So we can try idle case. So once we try idle case, yeah, now we got idle case correctly, right? You can see that all ones here, idle case predicted well, right, all of you. So the live classification working good. Once you check this, now you can move to the model deployment. So go to the model deployment because you are ready. Now where you want to deploy and what is the programming you want to use. Based on that, you have to choose the library. So C++ libraries are there, hard, Android. So you have different format developing libraries, Nordic, Mac OS, Linux, Docker, BrickML, custom software, Tensor. So all these libraries, we are interested in Arduino because we are using Arduino now, Arduino library. And this UN compiler is mainly to generate the inference engine, okay, which is optimized Arduino code. For that, you have to use this inference engine, right? And you can see here the quantized in date we are downloading. So this should be selected because this will take less memory when compared with this, because you can see all like 86.67, it is also 86.67. And latency here it is 1 millisecond, it is 3 milliseconds, so it is fast. And it is, you can see total latency 12 milliseconds only. RAM 1.4K, it is also RAM is very same. Okay, of you, right? And you can start building this. So now building the output. So it will take a couple of seconds, right? So actually, once it is done, you can get the, so you can see build Arduino library and it automatically downloads, right, all of you. So you can see here it is downloaded. EI, Hubits 1 project Arduino 101 impulse 1 zip, right? So this is a file, right, all of you. So you can go to this file. See, this file directly don't give all the code to you. It will only give you inference engine. Okay, that is inference code. So direct model, deployed model, you can use that. Okay, but it comes with all examples. Okay, actually we selected for ESP32, but it is giving all, right? So you can go to ESP32 and you can see, for example, it is giving some sample codes only. If you see this sample code, you can see here these examples, and then you can scroll down. So you can see this is the our Hubits 1 hyphen project hyphen 1 underscore inferencing.h. So this is the main model that we are getting. So we are using that model for predicting. Okay, so these are the examples how you can use it. Okay, so we created already program based on this. So you can see here. So you have to check it and you have to modify based on your sensor, because it is not giving fully everything more correct code, because it doesn't know what is the sensor you're using, MPU 6050 or other sensor. So based on sensor, it change, code should change, right? So I built previously. So here you have to change your inferencing, and then you have to upload. You have to upload and you have to test it, right? So I'll be showing you. So already I have uploaded because it will take more time to upload the program into the hardware. So for now, I'll be showing you. Already uploaded. I have uploaded the code into the board. So the code is already there. So, but that model is trained, not this model. This model is actually trained in the morning. We deployed on that hardware. It is connecting. 1 second. 1 second. I'll be selecting the board. Yeah, so what I have to do is I have to stop this. Okay, so what happens, it cannot use both. I have to stop this, okay, because it is also using serial monitor. So you don't see the output here because data is coming from the serial monitor, right? So port monitor command open failed, serial port busy. Somebody is using this. So this is actually for port forwarder is using it. So I'll stop this. Once you stop, you can see here data coming. 1 second. So data should come here. Now you can see here. So now he's actually, can you please try moving up and down? So yeah, it is detecting up and down because already we deployed. So you can see up and down is detected, right? And sometimes you are getting the wrong movement when you don't move properly, right? So now we are keeping no movement. So that is ideal condition. You can see that. So this is how you can actually do, directly deploy. So now this is actually AI deployed hardware where you can see how it is actually doing, right? So how many of you are able to understand, right? Following? Any questions, all of you? Yes. Any doubts or anything?
No, sir.
Yeah. So hope everyone understood how it is a very simple application we have seen, but there are generally there are sometimes very critical applications that we need to build. Okay, so in such case you need to work as a team, and you need to collect a lot of data and you have to train the model. Okay, and you have to optimize. So these things should happen, right, all of you. So this is about how you can deploy on hardware. Okay, so hope this is clear to you. And if anyone wants to know more, you can connect with us. Okay, you can connect with us if you are new to it, AI, IoT, hardware. So actually, we have a separate training programs also happening on AGI. If you are interested, you can just ping us there. You can learn more about hardware and also AI algorithms and how you can actually build the models. Okay, not only using Edge Impulse, you can create your own model and you can deploy on the hardware. How you can do that? Okay, voice assistant, if you want to build, how to build a voice assistant. So all these things you can do, right, all of you. So if you need anything, you can come to us. We are going to give certificates to everyone, right? So thank you so much for attending today's session. Okay, if you have any doubts related to career or anything, you can ask us. Thank you. Yes, Babu, Chaitanya, Daniel, Narendra, Pooja, Sangram, and Sarath. Thank you so much for joining. So
Thank
I'm
you.
open to, yeah. So please leave your feedback if you like this, or if anything you are expecting, please let me know so that in the next webinar we try making more better. Yeah,
It was a
so
nice,
Yeah.
it was a
Sarath,
nice session.
yes, Sarath, you are asking something, right? Can you please tell me again?
No, no, I didn't ask anything.
Yeah, okay, okay. Thank you. Thank you
Yes,
all. This all.
Bapuji, it was a nice session to get some good knowledge on that. And
Yeah,
hopefully, yes, hopefully we'll meet soon. You're in Vizag itself, right, sir?
yeah, wise, I guess.
Okay.
Yeah, thank you so much, Babu. It's a wonderful section. Actually, you have given a very, very good insight about Edge Impulse. And I have a few queries, like actually for is there any other open source platform like Edge Impulse to deploy in our own cloud server for enterprises level of usage?
Yes.
Is there
So
anything?
what you can do is you can try TensorFlow Lite.
Okay.
So you can write code in TensorFlow and then you can convert that into TensorFlow Lite. That is easy.
Okay.
So
Okay.
I'm sharing my screen so that you can see that. Okay.
Okay.
So this
And one more
one,
thing.
this is
Yeah, yeah.
actually,
Please,
yeah,
please.
TensorFlow Lite. You can just
Mm,
search for TensorFlow Lite
mm,
and you can find, now it is actually Lite RT. This is actually Google
mm.
product. You can go and see this. So this is actually becoming one useful tool which converts your TensorFlow program into TensorFlow Lite and you can deploy on directly on your hardware.
Okay. Instead
Yes.
of I don't want to depend on Edge Impulse. Okay.
Yeah, you can do it independently of any platform.
Oh, fine.
Yes.
Okay, that's one thing. Second thing is like okay, there's something. Okay, I suddenly forget the question actually. Uh, ah, okay. So I'm using I'm developing all my things in ESP IDF actually. Okay, so
Yes, yes.
instead of Android, sorry, Arduino Nano. So is it, how I can do the same in
Yeah,
IDF projects?
everything is there like in the IDF. So you can actually
Ah,
download ESP IDF deployment and you can directly integrate.
okay.
That is straightforward, like Arduino.
Okay.
Yeah.
Third thing is like, okay,
Just you
it's a
have to
very
change
good
the
session.
library. That's what you're doing. Yeah.
Okay, let me do some get chat GPT and let me learn
Yeah,
that.
sure, sure.
And one more thing is like, so okay, we need this kind of more paid training also is fine actually. Just plan and how to use NPUs. And I found a few of the boards in Rockchip. It's a quite cheapest boards like which is having NPUs on that actually itself, like RV1106 like that.
Yes.
So it will be useful for us to get into the Edge AI.
Sure,
So
sure,
we
sure.
like
Yeah.
to give more, provide more training. Even it's a paid training also. This is fine actually. It's more useful for us. Or it will be helpful for us to develop more products. So how to use NPUs and what is RKN
Yeah,
and
sure, sure. Actually,
those
we
things.
are in the same line. So sure, I'll do
Okay.
that.
Yeah, please, please.
So you're
Thank you
from
so
which
much.
country?
It's
Yeah.
Yeah, I'm a freelancer actually. So I
Oh, great.
used to work with L&T and Cisco. Now I'm doing a freelance projects. So
Wow.
I'm also a product developer in embedded industrial IoTs. Yeah.
Nice.
Thank you so much, Babuji. It's a very
Thank you.
helpful. This session is very really helpful for us.
Yeah, thank you. Thank
Yeah,
you so much.
thank you. Yeah.
So thank you all of you. With this, I'll be closing today's session. Thank you for joining. So yeah, all of you are here until our session is completed. Okay. Thank you. Thank you so much. With this, I'll be closing the session.
Thank you.
You
Thank
can
you.
leave. Yeah.